Okay, so this is a continuation of proof number 4. You should have the given statements written, and we want to come over and we want to really think through what are we trying to prove here. So we want to prove that triangle JMN, which is this triangle here, is congruent to LNM. So I marked the given statements here, but the reflexive property is one that we're going to see a lot in our proofs. So I'm going to mark this one with 2 markings because I know that these two this segment is congruent to itself. So now when I come over to my proof, I want to mark it, and then I also need to write the statement out. So MN is congruent to MN because of the reflexive property. When I look at it again, I need to ask, do I have enough information to prove that these 2 triangles are congruent? I do by side, angle, side, side, angle, side. So that's my last step. I'm just going to write the proof as we see it here, and our reason is by the side, angle, side theorem, we can say that those 2 triangles are congruent. Next we're going to look at number 8. So go ahead and get everything set up on your paper, write the given statements. So this is what you should have for your given statement. We're going to look over at our proof again, and this SQ bisects this angle RQT. So the word bisects is going to be really important. If we look over at our reference sheet here, we see reasons that angles are congruent. One is going to be what we call definition of angles, bisector. So if we're told that a line bisects an angle like it does here, then we just need to figure out what 2 angles are congruent, because if we bisect this whole angle, then that means that these 2 angles are going to be congruent. So SQ here bisects RQS, and it also bisects TQS. And so that word bisects leads us to our next statement here, which is going to be angle RSQ is congruent to angle TSQ. And that one, what I wrote, actually relates to SQ bisecting RST. I wrote that one first. So RSQ is going to be equal to TSQ. Then on the next line, I'm going to write what I said first, which would be angle RQS is congruent to angle TQS. And my reasoning for both of these is the same. It's the definition of angle bisector. I want to mark these on my drawing too, so I have that this angle is congruent to that one because this bisects this one, and then I have this angle is congruent to that angle there because QS bisects this larger angle. If I look at my diagram, I see I have the reflexive property again, so I can show that QS is congruent to QS, so that'll be my next step here. So I write QS is congruent to QS, and that's going to be the reflexive property. At this point I want to look and see, do I have enough information to prove that QRS, this triangle here, is congruent to QTS? Well, it looks like we do have an angle, a side, and an angle that's congruent to an angle, a side, and an angle, so we do have enough. So we're going to go ahead and write that statement. And the way it will look once you're done is we write what we're proving and put ASA. So that's another one done. Make sure that you're numbering all of these so that you know which ones you have completed. The next one we're going to look at is number 9. So again, write your given statements, get it all set up. Alright, so if you have 9 all set up and ready to go, it should look like this. We want to see what's our goal. We're trying to prove that JKL is congruent to MLK, so these 2 triangles. Now our clues here and our given statements are that we have some lines that are parallel. So here it says that JK is parallel to LM. So I'm going to kind of draw that line out so I can see it. Now if we have parallel lines, it looks like we also have a transversal. And a real key here is we are going to find alternate interior angles, but we need to be really careful that we choose the angle that goes from, like this one, a parallel line to a transversal, and a parallel line to a transversal. Okay, when we do that, we see that these are congruent, they're alternate interior angles. Do you see down here on this one, if you go from this line to that, you're not going from a parallel line to a transversal. This is the parallel line that I have drawn here. We do have another parallel line, so you'll see how that works. But just be careful to do parallel line to transversal. So we want to write this angle relationship out. So we are going to put on our sheet here that angle JKL is congruent to angle MLK. And our reasoning for that is alternate interior angles. Right. Now we want to look at the other parallel lines. Use a different color for that. So now we're going to say that JL, so this line right here is going to be congruent to KM. So if those are my parallel lines and this is my transversal now I can say from parallel line to transversal that this angle here is congruent parallel line to transversal to this one right there. So now I'm going to write down that those two angles are congruent. So go ahead and do that. Right, so check yourself and see that you wrote these angles correctly. You need to make sure that the beginning, if you wrote this one as angle LKM, that's fine. Just make sure the K was in the middle, and you do need an L and an M. And then same thing here, you could put KLJ, that would be fine, but the L needs to be in the middle. All right, so now we have these angles that are congruent, and we also need to see we've got reflexive property again. So I'm going to mark that as congruent, and when I mark it as congruent, I need to write it down. So this is KL, so we're going to say 5 here that KL is congruent to KL, and that is because of the reflexive property. All right, last up is now, do I have enough information to prove these two triangles congruent? Well, it looks like we do. I've got an angle, side, and angle for this triangle, and I have an angle, side, angle for this triangle. So I'm going to write down what I'm proving and put angle, side, angle. So go ahead and do that. All right, so that's your finishing line there, and we have proved what we set out to prove. Okay, so altogether with both videos, that's 4 proofs that we walked through. By now you should have an idea of kind of the format. And I'm going to go back to this reference sheet again because it is super helpful. The hardest thing about doing proofs is that you write the given statements and then you don't know what to do. But you always have clues in the given statement. So if you have parallel lines, here reasons angles are congruent are going to be, some of them, if you have parallel lines, you're probably going to be using one of these 3, alternate interior angles, alternate exterior, or corresponding. If in the given statement it tells you that something is bisecting, more than likely you're going to use definition of bisector. There are also vertical angles, which you're just going to tell by looking at the diagram. If it says definition of, or if it says that there's a midpoint, then you're more than likely going to use definition of midpoint to prove sides congruent. And then the reflexive property we just look at in the diagram. So this is really important for you to kind of know all of this so you know what your options are. It makes proofs much easier. All right, and that's it for now.